Hello, all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate generating a random number. Let me answer this question with practical demonstration. In Java programs, if you want to generate a random number, you can create an object for the random class and you can generate a random number using its object reference by calling some method. Let me practically show you how to do this. For that, I'll switch to Eclipse IDE and create a new class. I'll just name this class as random demo. Okay, random demo. Okay, generate random numbering demo. Okay, select some main method. And inside the main method, I'm going to write some code. Random is equal to new random. Random is equal to new random. Control Shift O. Okay, and after that, okay, and after that, you just write down random dot. Okay, here there are many methods here, guys. We'll go with, you see, you can generate some random number in the form of float, double, okay, integer. For example, most of the people go with integer. They generate the random numbers in the form of integer, int. And here we have to give the range. For example, if you give the range as 1, okay, that is the random number starting from 0 and less than 1 will be taken into consideration. Okay, int number is equal to, I'll print out the number. No matter how many times you run, it will print 0 only because do not even consider 1, guys. Okay, less than 1, up to less than 1, 0 to less than 1. Okay, run the code and see that in the output, you will get 0 every time. No matter how many times you run the program, you will get the output as 0. Run the code, run the code, run the code. Every time you'll get the value as 0 printed. Okay. And if I increase that to 2, there is a possibility that 0 and 1 will come now. Okay. Now there is a, you see, 0 is coming. Sometimes 1 is coming. 0 is coming. 1 is coming. 2 will not come, guys. 2 will not come. Okay. Only up to 1. Less than 2 will come. What if I give 100 here? It will generate a random number in the range of 0 to 99, not 100. Okay. So 86, just run the code, right click run as Java application. 75, run it. You see, below 100 should come. Okay, below 100 should come. 55, run it again. Then 91, then run it again. Then 54. You see, if I change it to 1000, okay, right click run as Java application. If you change it to 1000, you see 410 will come. 210, 71. You see, less than 1000, from 0 to less than 1000 will come. Okay, less than 1000 will come. 353, 621, 368, 705. Below 1000 it will come, guys. Okay, like that you can go up to any number that you want, integer number. The biggest range of integer number you can give here and get the random number starting from 0 to number -1. Okay, in the output when you run the program. So hope, guys, you got the answer for this question. That is how to write a Java program to demonstrate generating a random number. Okay, using a random class with practical demonstration have I covered in this session. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to get the IP address and host name of a machine. Let me answer this question with practical demonstration. Before I write a Java program to get the IP address and host name of a machine, I'm going to manually show you how to use your computer options and all to get the IP address and also host name of your computer machine. Okay. So first I'll show you how to get the IP address so that whatever the Java program is resulting as is really an IP address or not. Whatever the Java program is resulting in the host name, that is really a host name of this machine or not, we can find out. So I'll compare the manual results with the Java program results. So here I'll search for CMD in this Windows search box field. and open the command prompt. Once I open the command prompt here, in this command prompt, I need to type a command known as ipconfig command and press enter. The moment I press enter with this ipconfig, in the results, you will get this IP4 address. This is nothing but your IP address. You see, you cannot, select that part, right click here, and I'm not able to select this guys, okay? I'll do one thing, I'll just say Control C otherwise. Let's try this, Control C and see whether it is getting copied or not. Yeah, it got copied, okay? So manually, using my computer machine options, I got this IP address. Next thing about the thing is, I have to get the host name of my computer. To get the host name of the computer in the same search, Windows search here, just you need to search for about. Type about here, type just about, and here about your PC will come. Just select that about your PC, and it will take you to one screen where you will find the device name, which is nothing but the host name. This is the device name or host name. Guys, copy this and paste it here. Okay, this is a host name. This is the IP address of my machine, computer machine. Now, by writing the Java program, I would like to get the same thing. Okay, instead of using the Windows options and all, command line and all those stuff, I would like to write a Java program to get this IP address using the Java program and the host name, that is Arun Moturi, which is my computer host name, with the help of the Java program. For that, I'll create a new class. I'll just name this class as, say, class 2, some random class name, let's say class 2. Okay, with main method I'll create. Once I create this with the main method, here I'll write down some code, that is inet address. Okay, this is the class inet address dot. The moment I say inet address is one of the predefined classes in Java, and it has a lot of static methods, static predefined methods. One of such method is get localhost. Okay, get localhost. This get localhost method will return you an object of the inet address. Okay, so here you are getting a unchecked, checked exception. That is, Java compiler is suggesting that there's a possibility of exception here. Initially, I'll just ignore the exception using this by adding this declaration and just stating the mouth of the compiler. And later I'll have to add try catch block. Guys, in real time, I have to add try catch block. Over the mouse on this is returning the object of the inet address. So here, inet address or inet host address, inet host also you can say. Okay, inet localhost. It is returning an object of the inet localhost. Okay. For the mouse, create local variable. Okay, inet address, inet localhost. So I have created an object for this inet address with the name inet localhost. Okay, using get localhost method. Now using this object reference, you can call some methods, guys. Okay, that is dot get host address. Okay, when you say get host address, it will give you the IP address of your machine. Okay, for the mouse, create local variable. The return type is string. Get host address return type is string, that came here. And similarly, okay, you can also get the same object reference. You can use inet localhost and say dot get host name. This will give you the your device name, computer device name. Okay, so host name I'll say. Okay, host name or device name, whatever you can say, whatever the device name that we got will come. I would like to print it out. System.out.println. Okay, IP address of this machine is plus this IP address. I would like to print it out. Okay, plus IP address. And similarly, system.out.println device name or host name of this machine is plus host name. Like this, I'll write. I'll run the code here. I'll not get any exception. Generally, if there's no problem with this, you will not get an exception, but you'll get the result clearly. IP address of this machine is, you see, 192.168.137.1 is the IP address of this machine. Let's see and compare. Am I getting the same IP address? No, right? So maybe I did some mistake there. Again, I'll go to command prompt, cmd, command prompt. I'll say ipconfig and see whether there is a ipconfig. Is there anywhere it is matching? Yeah, this is the address. Sorry guys, I just took the wrong one. This one I have taken. I have to take this one. Okay. First one, wireless LAN adapter local area connection. This one I have to take. Control C. Actually, I did a wrong thing there. So the bottom one I have taken, the top one I have to take. Okay. Similarly, coming here in the output, the device name of this machine is Arun Motori. Okay, which is also matching. Okay. So this is how guys you can get the uh, IP address of your machine and device name or host name of your machine by using this predefined class in Java known as inet address. By calling the get local host method, you get the object reference. Using that object reference, you can call the get host address, get host name. To get the IP address, get host address. To get the host name, get host name is the device name, get host name. Okay. And also here, you should not be using this ignoring the exception that is given by the Java compiler. Better to surround this with try catch block. Okay. Better to surround that with try catch block. If in case there is a problem, it will take you to this thing. Okay. So you can write all this stuff. You see, without getting the inet, what do you do with this? Okay. Put all this code inside the try block, guys. Okay. So that it is a better way of writing the code, guys. Okay. So if this is not coming, then what is the use of this thing, right? So if an exception comes, there is no need of getting the IP address or host name. So all this related code you type inside the try block and catch block you write. This is how the people write the code for the stuff. Okay. So run the code and you'll get the same thing, same output. You'll get IP address of this machine is okay. So device name of this machine is Arun Motori. Okay. So this is how you have to write the code, guys. Okay. So you can take a screenshot of this code so that you can practice later. So hope guys you have taken the screenshot of this particular code. So with practical demonstration, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate garbage collection mechanism. Let me answer this question with practical demonstration. And before going to the practical demonstration, let me explain the concepts that are surrounded by this garbage collection mechanism in Java, because if you directly go with the program, you will not understand what is happening. You have to first understand the concepts. And once you understand the garbage collection mechanism concepts of Java, then you write the code. It will be very easy to understand, guys, what is happening. Okay. So first of all, this garbage collection mechanism in Java is an automatic memory cleaning mechanism. Okay. What is this garbage collection mechanism? It is an automatic, you can see here, automatic memory cleaning. Okay. Cleaning mechanism. That means developers don't have to break their head in worrying about whatever the objects that they have created while writing the Java code. They may forget to close the objects once the task is done, or they will forget to clear or remove the unused objects, which are no more pointing to any object reference or whatever it is. Object references are referring to particular object. Such kind of things need to be cleared from the memory. Okay. For that, developers can consciously, clean the stuff by themselves. But for their, betterment and to save the time of the developers, Java has come up with a concept known as garbage collection mechanism. So it automatically cleans the memory that is released by the objects once their task is done. Okay. So let me explain more, guys. Will understand. Okay. A lot of theory will be there. Don't worry. I'll just read it for you, and more you read, more the understanding you will get on the garbage collection mechanism of Java. First of all, here you see this point, guys. Garbage collection is a fundamental feature of Java that automatically manages memory by reclaiming the memory occupied by objects that are no longer in use. Once the objects are utilized and the program is no more using that particular object, that means the objects are no longer in use. But the objects that are no longer in use are still using some memory, are still consuming some memory. Okay, that kind of memory need to be reclaimed. Released by closing that objects or whatever it is. From that particular object, we have to release that memory once the task with the object that is created by the developer in the Java programs is done. And this can be done manually or automatically. How it is done automatically? If the developer has not manually cleaned up that particular memory of the object that is no longer in use, then Java has its own inbuilt garbage collection mechanism which looks for this kind of objects which are no longer in use, and once it identifies that objects that are there that are no longer in use, it will reclaim the memory, automatically manages the memory by reclaiming that memory back from the objects that are no longer in use, thus preventing memory leaks. Okay, if the objects are continuously consuming the memory, right, what happens? More objects will be created. Developers keep on creating a lot of objects, and the old memory will be there, new memory will be there. User memory will leak will happen. Okay, and memory management will be difficult if this kind of mechanism is not there. If developers have not closed that particular or not reclaimed the memory back from that objects that are no longer in use, memory leaks will happen, and proper memory management will not happen. Okay, so to help the developers, okay, the Java has provided this inbuilt mechanism known as garbage collection mechanism, which is an automatic memory management, guys. Okay, automatic memory cleaning mechanism from the no longer used memory objects. The objects will be memory will be reclaimed and released. Okay, Java's garbage collection mechanism makes memory management transparent to developers, allowing them to focus on writing the application. What the developers are already busy in writing lot of logic, guys, for their applications and all. Okay, they have to write lot of application logic. They don't have to worry about this memory management and all, like what things to be used for cleaning up the memory and all those stuff, right? So that's where Java garbage collection mechanism has inbuilt the memory cleaning automatic inbuilt memory cleaning mechanism where developers can focus on writing the code while Java garbage collection mechanism takes care of releasing the memory for no more or no longer used objects. Okay, I mean objects that are no longer in use. Simple words. Okay, so this is what is the point you have to know to understand what is Java garbage collection mechanism to help the developers in focusing more on writing the logic than worrying about what memory you have to handle, how to handle deallocate the memory from the no longer in use objects. Okay, don't have to worry about developers. Don't have to worry about that. Java garbage collection inbuilt mechanism will automatically clean the memory. Okay. So step-by-step process, I'll explain, guys. This how the garbage collection mechanism in Java works. I'll explain step by step. So step-by-step process to understand how garbage collection works in Java, automatic memory cleaning mechanism. Okay. First, object creation, guys. Okay. Generally, when you create an object in Java using the new keyword, memory is allocated for the object on the heap. Okay, heap memory. Okay, in the heap area, the memory will be allocated for this newly created objects. When developers write some Java code and as part of the Java code, they created some objects, right? The memory will be allocated for such objects in the which area, which memory? Heap memory. Okay, in the heap memory. So I'll explain more about this heap memory, where the memory will be allocated for the objects. The heap is a runtime data area from which memory for all the objects is allocated, used to store objects and their instance variables. Okay, so whatever the objects you create using the new keyword and whatever the variables of that particular class for which you have created the object, that instance variables, okay, object related variables of the class for which you have assigned the values, all this data and object related stuff will be object related memory will be stored in the heap memory, guys. The garbage collector manages memory allocation and deallocation on the heap. Okay, so garbage collection mechanism, what it will do once objects are created and all, okay, it will go to the heap area, heap memory, or heap area, which is nothing but one type of memory where objects and their instance variables memory will be, data will be stored in that particular memory. Once objects are of no use, there's no need of maintaining the memory, right? That is allocated. Once the objects become no longer in use, the garbage collector mechanisms directly goes to that heap area and find out all the objects that are no longer in use and reclaim the memory from them back. Okay, release the memory and stop the Java programs from leaking the memory, or proper memory management will be taken care of by the Java garbage collector mechanism. Okay, automatic cleaning process though. So once objects are created, guys, some memory will be allocated for this particular objects and their instance variables in the heap area of the computer, heap area of the memory. Okay, reference tracking. Second task, what will happen as part of this to understand this, once objects are created by the developers, reference tracking. Java maintains a list of references to all the objects that are currently in use. What are the list of objects that are currently in use? Okay, a reference tracking will be done. An object is considered in use if there is at least one reference to it. Okay, an object reference or something is currently in use if it has some reference. Okay, an object is considered, you see the reverse way I explained. An object is considered in use if there is at least one reference. Okay, if you say car is equal to new car, that new car is an object. A new keyword will create an object for the car. But who is referring that? That C1 car C1 is equal to new car. Let's say C1 is a reference to that particular object. If you remove that C1 pointing to that particular object, right? That object will become no longer in use. Okay. Using the object reference only, the object will be in use. If the object reference is pointing to some other thing other than this object, and that object will become no longer in use. Okay. So what are the kind of objects which have some object references pointed to it that Java will track? Third thing is, as part of garbage collection mechanism, once objects are created, object memory will Java will create the, allocate the memory in the heap area, okay, for that objects and instance variables, and then it will start tracking the, if there are any references to this particular objects, okay, then marking phase. Now, next one is marking phase, guys. Periodically, the garbage collector runs in the background, okay. In the marking phase, periodically, the garbage collector runs in the background. Java garbage collector runs in the background of the, okay. During its execution, it traverses through all the reachable objects, starting from the root objects and marks them as reachable, okay. All the objects are reachable or not. They have some reference, and using that references and all, in the marking phase, Java garbage collector mechanism will travel through all that paths to that particular objects, from root objects to the whatever the objects that are created. Okay, are they still in use or not? They want to check. Then sweeping phase. Sweeping phase is a phase where in Java garbage collector mechanism, you don't have to remember all this theoretical stuff. Try to understand it. Okay, if you are able to understand what is going in a Java program, you'll understand. Okay. In sweeping phase, Java garbage collector, after making all the reachable objects, the garbage collector scans through the entire heap. Yeah, in the heap area only object memory is created, right? And it identifies the objects that are not marked as reachable. Okay, if any particular objects are not reachable, okay, while in the marking phase, the garbage collector runs in the background and it will travel through all the reachable objects. As part of that process, in the sweeping phase, entire heap, it will, after marking all the reachable objects, the garbage collector scans through the entire heap and identify objects that are not marked as reachable. If there are any objects that are no longer in use, okay, not reachable means no longer in use. These objects are considered garbage and are eligible for removable by Java garbage collection mechanism. Okay, collector or collection. Java garbage collection mechanism. Okay, so next thing is reclaiming memory. Okay, I'm just getting one doubt, guys. Let me get that out. Java, I'll just type here Java garbage collection only. Okay, collection mechanism. Okay, so reclaiming memory, last phase of the Java garbage collection mechanism. Once the Java garbage collection mechanism collector identifies that there are some objects which are no longer in use after marking phase and sweeping phase, once it identifies that, it will, okay, once the garbage collector identifies the garbage objects that are the objects which are no longer in use, it deallocates their memory from the objects and making it available for future objects allocation. Okay, so that memory will be reclaimed. So this is how the memory management will be done in a step-by-step manner by this Java garbage collector mechanism. Okay, which is an automatic process, guys, automatic memory cleaning mechanism. You don't have to call it or something. It will automatically do its work. It will run in the background. Automatically, it will clean it whenever it comes across according to its algorithm and all. It will do that. What as developers we have to do as a best practice to not rely on garbage collection mechanism in Java. For example, if you are the developer, you have the time and you have the time apart from focusing on the code, and you want to be following some best practices, and as part of best practices, you don't want to give the headache to the Java garbage collection mechanism. Rather, you want to do it by yourself, that cleaning process. Okay. So here Java garbage collection mechanism is like a maid. Okay. Let's say at your house, you have appointed a maid at a particular time. The maid, whenever the maid is free, the maid will come and sweep your house, clean the utensils, okay, wash your clothes, Okay. And then, if required, she will prepare food and all those stuff, whatever the maid has to do, and she will go off. Okay. He or she will go off. Okay. That's what is the thing, right? So here automatic, maid will come and go. Now, what about you? You yourself, you want to clean. You don't want to rely on the maid. Let's say I don't want to rely on a maid. I want to do my own work. Okay. I want to clean my house and, I want to wash my clothes. I want to do clean my utensils and, all the stuff. Okay. Prepare my own food and all the stuff. In that case, okay, I don't want to rely on that maid, right? So in that case, also there is a possibility, like if you don't want to rely on that automatic memory cleaning mechanism, which is done by the Java garbage collection mechanism, okay, then what are the ways? Okay, you have to do it by yourself. Okay, whenever. Okay, so developer here is yourself, like you are the developer, and maid is someone who is automatically coming and cleaning your house and going up. Okay, that's the thing. So what as developers we have to do as a best practice to not rely on garbage collection mechanism in Java as part of cleaning up the unused memory. Explicit resource management. Okay, explicitly you have to manage the resources, guys. You see, you have to use something like use try with the resources statements. I'm going to practically demonstrate all these examples for you guys. Don't worry. Okay, there is something like whenever after you create an object and if some memory leaking is happening, you have to use try with resources statements to automatically close that clear or release the memory of that, but close the objects by clearing the memory. Okay, there is separate close method also, guys, that you can use in try catch finally blocks or some finally blocks. You can use whether the exception is coming, whether the exception is doesn't coming. You want to close that. Okay, I'll explain all this stuff, guys, with try catch block, without try catch block, all the ways I'll cover. And then implementing auto closable interface. There's one more thing like auto closable interface by making a particular class. Implementing this auto closable interface also you can do. What is the purpose? For custom classes. Okay, here there are some predefined classes in Java, right? They may leak the memory. For that, you will use this try with the resources or close methods. But when you have your own custom classes and you want to make a customized, okay, cleaning mechanism for them. Once you can create some user-defined class and you use that, but you create an object for that class and you want to create a customized way of cleaning that particular object and releasing all the resources utilized by the object in a proper process. Then you can use this auto closable interface you can create, and you can make a particular class, implement this auto closable interface and get the cleaning done. Okay, this is explicit, it's not automatic. Java garbage collector mechanism, if you don't even use explicit resource management, also can automatically memory clean. Okay, it will automatic memory cleaning mechanism. Okay, but here if you don't want to rely on this Java garbage collection mechanism and you want to clean by yourself, then you can use all these methods, guys. There are multiple ways. Three top ways I'm giving you. I'm going to demonstrate all these things with practical demonstration. There are some not good practices also. There are some ways to clean your mention Java to invoke the garbage collector mechanism. Instead of making the garbage collector mechanism whenever it is free, it will come and clean your unused object memories, right? You can insert the garbage collector mechanism. Okay, you can instruct the Java garbage collector mechanism. You can invoke it, you can call that and give an instruction to clean in this case. Okay, but that is not a good practice, guys. You should not be doing that, but I'll show you practically how to do all this stuff, but it's not really required. Explicit resource management you can do, but this kind of bad practices do not follow. Should not explicitly write system.gc kind of stuff. Should not be invoking the Java garbage collector mechanism, even though the Java provides a mechanism where you can write the Java code. Once the object becomes unused, you can call the system.gc to explicitly call, and instead of automatic, explicitly you are calling the Java garbage collector mechanism to clean the objects, unused objects for you. Let's understand about this system.gc, where even though Java garbage collection mechanism does it automatically, but we can use system.gc explicitly, is generally not recommended as a best practice for cleaning up objects in real time in Java. You should not be using this process, guys. But how to use, I'll show you, but you don't have to use. It's like asking teacher a question and waiting for the answer, guys. Okay. So, teacher is about to explain some topic. Before the teacher explains the topic, you're asking a question. Okay, for which the teacher already is planned. When the teacher want to explain something, before itself you are asking a question to the teacher or trainers, like, I have this question. Okay, that kind of situation is happening here, guys. Teacher is anyhow going to explain you some topic, the coming thing, but you are very curious and you are very, kind of situation where, you thought that, you thought like teacher will not do that. And with that intention, you asked teacher a doubt. Teacher, I have this doubt. Okay. Now, teacher will say that, okay, beta, you wait. Okay. Okay. You just wait for some time. I'm going to explain this topic. Or if the teacher feels that the particular question has been asked at the right point of time, the teacher is available free and all, then teacher will immediately clarify your doubt, or the teacher will say that just wait for some time. Okay, when the time comes, I'm going to cover this topic, you'll understand this question. Okay, like that. Similarly, Java garbage collection mechanism is something like a teacher only. Okay, at some point of time, it will come and do the activities, cleaning activities, and release the memory and all. But here, you're forcibly asking the question to the teacher when the time has not come. Okay, so teacher may ask you to either, if the question is irrelevant and is a context at the same time you're asking, and the teacher is free, means directly teacher will answer the question. Otherwise, teacher will say you just wait for some time. Okay, I'm going to answer your question. It's going to come up. Okay, like that. Asking teacher a question and waiting for answer, teacher may answer later, not instantly sometimes. Okay, that kind of situation will happen when you say system.gc explicitly when you call, right? It doesn't mean that forcibly you're asking the teacher to, okay, do it right now. Kind of thing will not happen, guys. Teacher may take the time. Okay, Java garbage collection will take the time, even though that instruction has come to Java garbage collection mechanism notice to clean that object memory. Java garbage collector based on its priority and process and strategy, it will go and come using the algorithm. It will come and clean then only, but it will not worry about whether you have cleaned it or not. Okay, if it is free, it will do that. Explicitly calling system.gc can sometimes degrade the performance. By doing this, what's happening? Teacher is in a flow of explaining something. Suddenly, in between, you are asking the question. The flow will be disturbed, and because of that, teacher has to take more time to explain you the concepts, right? That's what you can correlate with the teacher example here. Okay, you're continuously disturbing the teacher. Teacher, what is this? What is this? What is this? Like that. Okay, teacher cannot focus on the concepts, right? Teacher cannot focus on the concepts, and the flow will be disturbed, and teacher will take a lot of time. Similarly, if you in your Java programs, if you explicitly keep calling system.gc to instruct the garbage collection mechanism to clean that release the object memory for the unused objects, the teacher may not be free, and so it may degrade sometimes. It may degrade performance by unnecessarily triggering garbage collection when it's not needed, leading to potential application slowdowns or passes. Okay, it's generally better to allow the JVM to handle garbage collection autonomously. Okay, Java JVM will do the Java garbage collection mechanism. Okay, okay, based on its heuristics, means its heuristics are like ideas or thought process. Okay, upcoming thought process or ideas, you can say, and its strategies, maybe you can call it anything, and some algorithms will be there that written by the Java developers, and how Java garbage collector has to go to a particular object as priority basis and then clean the unused objects. Okay, which object need to be really cleared from the memory and all those stuff. Okay, unused objects, which one should be done first, which one should be done second. Java garbage collector has to take that call. If you're disturbing like that, it will impact the performance. Okay, it's better to allow the JVM. Just give the freedom to the JVM and go and do that. Okay, clean that thing. Instead, the preferred approach for managing. Okay, if you don't want to use system.gc, and still if you don't want to depend on Java garbage collection mechanism, and if you want to really clean it by yourself, okay, don't use system.gc. It's also invoking the garbage collection mechanism only. But instead, you can use another approach, like instead of these bad practices, you can use a good practice. Like instead, the preferred approach for managing resources and memory in Java is to rely on the JVM's automatic garbage collection mechanism and to use proper resource management techniques, such as either you have to rely on the automatic memory cleaning mechanism by Java garbage collection mechanism, or you can use something like try with resources. Already I mentioned here, try with resources, explicit close method, or you can use using the by creating customized cleaning processes by making a particular class implement the interface like auto closable interface. Okay, and get the things done for all this variety of ways. Okay, instead of you depending on that. Okay, the bad practice I'm going to show, and good practice also I'm going to show. Okay, explicit resource management, some good practices are also there where you can use try with the resources or close or implementing auto closable interface. By that also you can clean up the unused memory there itself as a good practice. But as a bad practice, you should not use system.gc for this purpose. I told you the performance will get impacted, so it's better leave it to Java garbage collection mechanism instead of system.gc. But if you want to be yourself and if you are not a you are a developer and you are focusing on the code, but you have some time, let's say, you can clean up the memory there itself instantly with the help of this try with resources, close methods, and these are the better ways. Okay, if you don't want to leave it to Java garbage collection mechanism. Okay, so practical demonstrations, guys. All this, 4 examples. If I explain all these 4 examples for you, you'll understand, guys. Now theory is fine, right? Theory is fine, right? Now let's go into the practicals. First example, guys. Okay, first example is like, I'll use system.gc, which is not a good practice. You should not be used system.gc, but I'll explain you how to use that. So I'll create a new class, guys. Okay, I'll just name this class as okay. I'll just name this class with something, guys. Vehicle class. Click on finish. Inside the vehicle class, you create a main method, public static void main string or string of. Okay, string of args. Like this, you write the main method. Inside the main method, you create an object for the vehicle class. The same vehicle class, you create an object. Okay, vehicle v1 is equal to new vehicle. Like this, you create an object for the vehicle class. And now this v1 is object reference, which is referring to this object. Okay, new keyword is creating an object for the vehicle class in the heap memory area. Okay, and to this object, any references are there? Yes, v1 is the reference. Now, if I say here, no problem. Okay, the object is there, and you see, there's no problem here. Okay, there's no problem. So now I'm going to write some code, guys. That is, I'm just going to write some code, guys. Just give me a second. So here, object 1 is equal to null. Here I'll say v1 is equal to. Earlier, v1 is pointing to what? This object of this vehicle class. Now v1 is equal to null. Now, moment I update the value of this v1, right? Now v1 is not referring to this particular object, rather v1 is pointing to null. Okay, v1 is no more pointing to the object of the vehicle class, rather v1 object reference is pointing to the null, that is no object. So in that case, what happens? This particular object that you created is of no use, right? What happened in the memory, I'll tell you. The moment in the first line vehicle, v1 is equal to new vehicle means in the heap memory, let's say in the heap memory, okay, some memory will be allocated for this particular a vehicle object. Okay, let's say this is object one, and here some memory is allocated. Okay, some memory is allocated for this object, and v1 is the object reference for that. Now what I am saying? Now I am saying this v1 is equal to null. Null means nothing. Should not point to anything. This old connection will be lost. The moment you assign null to this v1 means v1 is no more referring to this particular object. So there are no references to refer to this particular object. That means this object is no longer in use. That's what Java will find. Java automatic garbage collection mechanism will come and automatically find out that there are no references like v1 or some kind of references. No more references are pointing to this kind of object. This object is of no use. Let's clean it up. Automatically it will clean it up. But if you want to instruct the Java garbage collection mechanism explicitly saying that, okay, how to instruct the Java garbage collection mechanism? System.gc, right? System.gc. Then what you are instructing is, you are instructing the Java garbage collection mechanism to go and please clean this. This v1 has now become unusable because it's now pointing to null. You can clean it up. That's what you are. It's not a good practice, guys. Okay. It's not a good practice. It's not a good practice to use this system.gc and instruct, because anyhow the Java is going to do that, right? Why you have to instruct that here like this? Okay. And anyhow, if the Java garbage collection mechanism is like a teacher, if it is kind of busy, it will not go and clean it right away. The garbage collection will not be happening in a instant. It will not happen based on the availability of the Java garbage collection mechanism according to the algorithm and processes and all. Then only the cleaning will happen, guys. It will not happen immediately. Okay, fine. Now, the object class has a predefined method. Okay, this code is not completed yet. Okay, object garbage collected. Okay, when I can know that this GC has requested garbage collection, and when can we know that the Java garbage collection mechanism has come and actually clean it? So to know that, we have to create this method from the object class and override this. Okay, this object class is a parent class of all the classes in Java, and you try to override that particular method inside this class. Okay, every class in Java is a child class of object predefined class, guys. Okay, so here I'll write some code like public void finalize. Can I use public or not? I don't know, but I'll use finalize is a method. Okay, finalize is a method, guys. Then write like this. It's allowing system.out.println, system.out.println. Here object garbage collected is not a good practice, but still I'm showing you how that is going to work. Here is this particular finalize method is overriding the method of its vehicle. Every class has a parent class known as object class in Java, guys. It may be user defined class or predefined class. That method is being overridden or not. Overridden. Override, otherwise override. At the rate override, if you provide means if it is really overriding, if I say X or something, right, you'll get an error because there is no particular method in the parent class of this vehicle class with the name finalize X. So this kind of annotation, if you put, you will come to know whether its overriding is being successful or not. If you remove that, you see finalize method is there in the parent class of the vehicle class or any other class in Java called as object class, and that method we are overriding. And when you call this finalize method, Java finalize method is called means that is nothing but Java garbage collection is done. Okay, object garbage is collected. That proves that. Run this code and see what is happening in the output. Whether the finalized method is being, you see, object garbage collected means garbage collection has been completed, but this is not a good way. It will impact the performance, guys. This is one of the program I wanted to demonstrate. So anyhow, if you want to take a screenshot, you can take more programs are there, guys. Is one of the program. So where you can explicitly invoke the garbage collection mechanism. So take a screenshot of this, guys. Hope that you have taken the screenshot of this. Now let's move on to the next one. That is example 2. This is not a good practice, guys. This is not a good practice. Not a good practice. Don't do this. Don't use this. But when the interviewer asks you to explain about the Java garbage collection mechanism in the terms of program, say that it's not a good practice. Good practice, but this is how it can be used. Then example 2. I told you, right, the best ways are explicitly, if you don't want to rely on the automatic Java garbage collection mechanism, you have to use either try with the resources statements or close method or implementing auto closable interface. I'm going to show you the first way, that is try catch finally block. Okay. Try catch finally block. I'll tell you what is try catch finally and all those stuff. Okay. So don't worry. I'll just create a new class. I'll just name this class as class 3 with main method I'll create. Okay. Here, I'm going to use something like buffered reader br is equal to new buffered reader. Okay, like this I'll create an object for the buffered reader. Control Shift O. Buffered reader will be imported from the java.io package, and this constructor cannot be empty, guys. We have to add the reader to it. So what is that reader? File reader. Okay, file reader fr is equal to some Java file handling mechanism code I'm writing as an example here, guys. I'm using that file handling mechanism of Java, and Control Shift O, file reader will be imported from Control Shift O, file reader will be imported from java.io package, and the constructor again cannot be empty, guys. So hover the mouse on the file reader and observe that file we have to pass. Let's represent a file1 is equal to new file of. See any particular file is there in this project that you have created earlier. abc.txt file is there. That's it's a blank file. We'll try to take some file which has some text or something. Okay, here some motori.txt file is there. I'll give that. Here directly under the project it is there. Directly you can give motori.txt file. That is enough. Control Shift O. File will be imported from java.io package. Now this file1 you pass it to the constructor of the file reader, and this file reader object reference you pass it to the constructor of the buffer reader. Okay. Now I'm getting a possibility of exception here. I can use try catch blocks or ignore the exception for a while. Now you see, guys. Okay. Now you can read the things, whatever the text you want to read from the motori.txt. You just try to read br.read something like read line. This will return you string read line 1. Line 1 is equal to, okay, whatever the text that is, okay, read line is returning what? You can ignore the exception, guys. Whatever the exceptions you are getting, ignore that for a while, because otherwise program will become very complex. Focus only on the Java garbage collection mechanism or other ways of closing the objects and all those stuff. Okay. So here I'm printing out that line 1, whether the line 1 is getting printed out or not, line 1. Okay. Now you see the task is done, guys. When I run the program, you see the task is done. But there is a problem in this program. I'll tell you what is that problem. You see, the text has been read from the motivator.txt file. Whatever the text that was there in the motivator.txt file, buffer reader was able to read it using the readline method. But the problem here is program is working fine, but you see the Eclipse IDE is making the Java, give some warning message saying that as a good practice, resource leak is happening here. This BR object reference is never closed. Once the task is done, once you have read the text from the text file, at the end you have to close it, guys. For that you have to write br dot close, br dot close. You see, explicitly you are closing, guys. Okay, here one of the way I told you, right? Explicitly you have to close it. Explicitly close it. Okay, explicitly we have to close it. That's fine. Explicitly we would like to close. That's fine, guys. Okay. So now, as a best, you say warning message is gone once you mentioned br dot close, right? So there are some predefined classes in Java, guys, for which if you create an object, Eclipse IDE will clearly, and during the compile time itself, the Java compiler will clearly mention that with a warning message saying that you have to close that particular object, guys. Okay, as a good practice. Okay, whenever the warning messages come, you can close it, right? The warning message will go up and the program will work as it is. Okay, here Java, here the memory is cleaned already, guys. Okay, the object garbage is already collected, memory is cleaned, from resources actually relieved from memory leak, because we are not giving the task to the Java garbage collection mechanism. Instead, we are closing the object once the task is done. Okay, that's good. Next thing is, now I removed all these things, right? What if in case you will get a exception? Okay, I'll write all this code inside. I'll put all this code inside the try block, guys. Try block. All this code I'll put in the try block, let's say. Okay, try. Here I'll write catch. I'll say some exception. I don't know what exception will come. E. Okay, I'll just write a parent class, IO exception or whatever the exception. System.out.println. I'll just say exception handled. Exception handled colon plus E I'll write. Okay, for example, assume that. This is the code I will write. But there is a problem in this. What if the exception occurs here? For example, here motor.ex I'll give. What happens? I'll write system.out.println, system.out.println, end of this program. I'll say end of this program. I'll say, okay. Now run the code, right click run as Java application and run the code, guys. What is happening? You see, exception got handled. Which exception? File not found exception is there. You can directly put file not found exception here also. That's okay. The whatever the file name you gave here, I intentionally mentioned X here. Motori.txt is there, motoriX.txt I mentioned. That's the reason it's not able to find the file, guys. Exception handled, file not found exception. The system cannot find the file specified is coming. Okay, end of this program got printed because the exception got handled, end of this program got printed. But do you think that the object reference, this BR memory, whatever the for which the memory is leaking, memory leak is happening, that BR, is that br.close is happening here? No, it didn't get executed. Why? Because here itself the exception has come. Here itself the exception has come. Remaining lines of code will not get executed. You see line 1 didn't get executed. All these lines will be skipped and directly exception got handled, and you see you have not closed the object. Once it is of no use, you have not closed it. That is the reason this is not the best place. So can I put in the catch block? What if the exception doesn't come? Can the object will be closed? No. So that's the reason Java has given a mechanism known as finally block. Okay. So to close that kind of objects, there is a mechanism known as finally block. Here error is coming because this BR is not declared outside the try block. It's local to the try block. BR is equal to null, and here double declaration you remove from the BR. That's it. Okay. Now over the mouse and say again surround with try or ignore the exception for a while. Okay, that's okay. Okay. So if a particular okay the particular whatever it may be the reason, guys, okay, for example, whatever the may be the reason, whether the exception occurs or exception doesn't occur, it will go to the finally block and it will close the object. Okay, run the code. In this case, the object will be closed, guys, no matter what, whether the exception comes and go to the catch block or exception doesn't come and directly go, finally block will be executed no matter what. So this object will be closed. That's how we use best practices in Java for cleaning the objects in our own Java project programs itself. Okay. Use try with resources statements, close method. Okay. Close method. And next one is implementing auto closable inter. Okay. So here try with resources is also there, guys. I'll tell you what is try with resources. Instead of separately giving the finally block here, right? Just take a screenshot of this, guys. Just take a screenshot of this code. Okay. Just take a screenshot of this code, how to use a close method. Then there is one more thing, guys, that is there's one more thing, that is you can use try with resources, guys. You can use try with resources. There is no need of writing the finally block in the latest versions of Java, right? This finally block is not required. Instead, you can put circular brackets with after the try, and here you write the code. Here file, reader, everything will go outside here. And this buffer reader, control X, buffer reader is equal to, you write it here, okay? Whatever the object that you want to close, you can close it here itself, guys, okay? BR is equal to control X and here directly, okay? This one is not required anymore, okay? So like this, guys, okay? So if an exception comes also, okay, the object will be closed. You don't have to provide the finally block here. Try, this is called as try with resources. If you provide that object that need to be closed, whether the exception comes or doesn't come, instead of using finally block in the latest versions of Java, you can use this, you just create the object in the try circular bracket itself, where the object will be automatically closed. Okay, this is another try with resources. This is what is called as try with resources, guys. We should not be, it's not required to use finally block anymore, a separate block. Rather, whatever the object that need to be closed, whether the exception comes or whether the exception doesn't come, okay, will be closed here, guys. Okay, will be closed here. Okay, the object will be closed no matter what. The object will be closed no matter what here. Okay, fine. So that's another thing, guys. Run this code and see. No exception will come anyhow, but the object will be closed in this case. I cannot show you visually. Okay. Try with resources close method, implementing auto closable interface, guys. Next one is implementing auto closable interface. Okay. So what is that interface? I'll tell you. Try with try catch finally, and other one is try with resources. I covered here. Try with resources also I covered. You can also create something like that. If you don't want to make this part of this, you can do one thing. New file reader of file one, you can say, okay, in that itself you write down, Control V, in that itself you write down, instead of new file, you just write the new file here itself, okay? So that everything will be there in the, you don't have to write this code anywhere, okay? In the try with resources only, the code is there, okay? The buffer reader, and anywhere the exception comes also, this BR object will be closed, okay? BR object will be closed no matter whether the exception comes or not. BR object, if it is created, will be definitely closed, guys, okay? This is called as try with resources, guys. This is called as try with resources. Compared to the normal try catch block, try with resources will have a circular brackets. In the circular brackets, whatever the objects you want to automatically close, okay, without giving the chance to the Java garbage collection. If you want to automatically close, close it once program runs, right? Once the task is done of this object, try with resources will take care of that, okay? So then that is called as try with resources, guys. I hope you understood what is try with resources. Yeah, next one is this one, guys, that is implementing auto closable for customizable, okay, objects, okay, customizable way of cleaning the or releasing the memory of the objects. For that, we'll use this one. I'll tell you how to do this step by step. We have to do, guys. I'll go here. Hope you have taken the screenshot of this. You have taken the screenshot of this, then we can move on. Now let's move on this and then write down new. I'll just give some name like class 4 is the name, guys. Okay, class 4 is the name. I'm creating a class known as class 4. Let's see here. It's kind of different. So here, class 4, in that main method, I'll create, first of all, I'll create a main method. Public static void main string of args. The program execution will start from this main method. Program execution will start from the main method. Okay, then public class name. Try with resources is being used here. But here in try with resources, custom resource you are using, okay? Custom resource, you have to create another class known as custom resource or whatever it is, which will use a close method to close it, okay? If it is closed, it will print out that resource has been closed also, okay? So let's do it. Actually create another class, guys, that is class custom clean, anything, custom clean class. You can give any name, guys, that's okay. Implements the interface known as, what is the implement? Auto closable interface, okay? Auto closable interface, you write it, okay? Now hold the mouse and it will ask you to implement the unimplemented method, that is nothing but the close method. So here write down the whatever the code, okay? Once this close method will close the object, guys. Right? This close method will close the object. Object, what is that? Resource closed. Object closed or resource closed, whatever. Okay, object closed. What object will be closed? That we have to write it here, guys. Okay. Suppose you create an object here. You can write in try with resources, guys. For better purpose, you can use try with resources, and try with resources will, the try with resources, try. Okay, catch. Okay, so here try with the resources. In that, create an object for this custom clean class so that it will clean the resources. Okay. CCC is equal to new custom clean class. Like this, you create an object for the custom clean. Try to create an object for the custom clean class. Okay, custom clean class. You create an object, guys, and once you create an object, right, this object need to be closed, right? That object need to be closed. If it is auto closable, means it will be automatically closed, guys. Okay, it will be automatically closed. Write the catch block or something here, and what I can do here, some exception E, exception E, exception E, exception E, system.out.println. I'll print it out. And here, if you want to do any operations with this object, let's say object reference dot, to string, okay, then it will return you the string method, string, okay, string, object string is equal to, then system.out.println and do some operations on the object, guys. It's not compulsory that you do some operations on the object. You just try to do the operations of the object. Once the operations on the object are done, this try with resources will automatically call this close method and will print out saying that earlier we didn't, with the try with resources, we didn't get any message, right? Like object got closed, object memory got released, okay? Object memory, object got closed, and its memory got released. Okay, this is another way developers can use, like, custom clean classes they can create, and they can implement the cleaning mechanism in that classes only. Okay, whatever the classes objects that you want to clean, right? It can be any other class, guys. Okay, tomorrow it can be car class, bank class, any class. Okay, if it implements auto closable and overrides the close method, right? Then you can use try with resources in your program whenever you create an object for that particular classes, right? So you will be automatically closing the resources and releasing the memory of that particular user-defined classes. Okay. For that reasons, we'll use, guys. After the task is done, the resources will be cleaned. You can run this code and see that the program will run. Object string will be printed. After that, object got closed and its memory got released. Okay. This kind of things you have to practice, guys. So if you want to practice, this, just take the screenshot of this code, guys. Okay. It can be any class, guys. Hundreds of classes can implement this auto closable interface, and and override the close methods of that interface to close the objects here that are put in the try with resources kind of, okay, try catch block kind of thing, try with resources catch try catch block, okay, which will automatically clean them. Okay, custom cleaning mechanism we are providing for the classes, guys. Okay, here you can write any other code. Okay, anything you want to implement during the closing of this particular object for this class, right? What is the process you want? That customized process you can write inside this close methods. Okay, so here I'm simply putting print statement to show that the cleaning is happening. But in real time, developers can write what of any database connections has to be released or whatever before deleting the releasing the object of the memory and all. Everything, that all this code they can write here, and once they use this here, and auto cleaning mechanism, this cleaning mechanism will be triggered the moment the object usage is done. Okay, fine. In the try with resources blocks. Fine, guys. Hope you got the idea what exactly it is. These are the multiple ways of the garbage collection mechanism, guys. You can explain as much as possible if you get this kind of question in the interviews, guys. If you get this kind of question in the interviews, right? Write a Java program to demonstrate garbage collection. These are the different ways you can handle that. So by default, Java garbage collection mechanism, right, happens automatically. You can invoke it. Basically, you have to write this program and say that this is not a good practice. Then if the if the interviewer asks that, okay, this way of garbage collection mechanism is not good, if you say, and when you try to write the program and show this system.gc being used to release objects and all, okay, then you tell the interviewer that, this is not a good practice, it should not be used by developers, it impacts the performance and all. But then interviewer will say, is there any other way to, solve this problem? Then go and explain all these programs. Okay, there are other ways like try with resources, or try close method, close method of the, particular objects, then try catch finally block. Okay, then you can use this, we can create customized closing mechanism, cleaning mechanism for the classes, objects created for the classes by making the classes implement the auto closable interface. All these ways you try to demonstrate, guys. I know you have learned a lot today from this answer. It's just not a answer for this question, but any other questions you get from the garbage collection mechanism, you'll be able to answer now. So such detail I have explained for you in this session as an answer for this question. Now with this concept, you'll be confidently able to answer the questions in the interviews. Okay. So that's all for this session, guys. Thank you. Bye-bye.